Our world and the way we live has changed dramatically over the past few years. The internet has revolutionized the way we communicate, the way we work, the way we spend our everyday lives. The more we use it, the more dependent we become to access it whenever and wherever we need to. Whether we are high above the clouds in a plane or in the midst of the ocean on a ship, this is a huge technological challenge. At the University of Luxembourg's Interdisciplinary Center for Security, Reliability and Trust, a team of computer scientists and engineers is working on a solution. How can high-speed internet be made available in remote areas, over the ocean, or in the skies?
This is where you need the satellites, because you can access the satellite wherever you are. You just have to look at the sky. This is the advantage. The disadvantage is that the satellite is very far away and the amount of data that you can send through it is rather limited. So the solution that we are proposing essentially is using the satellites to provide high-speed internet access when you are in these remote locations or when you are in vehicles like ships and planes. And the best thing of all is that it's rather simple to do and it's cost efficient.
In the Luxembourg National Research Fund research project Serenade, principal investigator Simeon Hachinotas and his team focus on satellite multi-beam broadband systems. They focus on what happens on the ground before the data is sent to the satellite and after it is received by users. By redesigning the algorithms of gateway modems, they found a way to process the wireless signals more efficiently. Now, the transmission over satellite has more throughput and improves system flexibility across the coverage area.
The solution that we are providing compared to the past will allow many more users to be connected. Usually you have a satellite which flies very far away from the Earth. This satellite transmits to the ground using different signals. Most of the times they use 4 different signals. 1, 2, 3, 4. And this is because we don't want the signals to be mixed with each other. But now we have been trying to look into new ways of doing this. And the idea is that we process the signal so that instead of 4 different single beams, we have one large, very powerful beam. And with this powerful beam, we can serve the same users that we did with the separate beams. Since you are using all the resources of the 4 beams to cover this entire area, the users will be able to get much better speeds and much better quality of experience.
Right now, satellites reach users by sending multiple individual beams to a wide area. We propose using powerful, flexible beams among all users. User modems report their current conditions and traffic requirements to the gateway. Based on that, the gateway designs the pre-coded signals for each user. The pre-coded signal is then transmitted back to the satellite. This leads to a system throughput that is up to 4 times higher, along with a flexible allocation of this throughput to system users. The end result is high-speed internet access wherever you can look at the sky.
These are all the flights that you have going from the US over the Atlantic to Europe. And this is only part of the world. So imagine how many people are on the sky every minute of the hour. So the idea is that all these people would like to have the same kind of access to the internet and with the same affordable manner as they have in their house. And this is what our technology is enabling. You could essentially quadruple the amount of data that you send to these users by just changing your ground equipment. All of these planes will be able to get high-speed internet. People will be able to communicate with their relatives, to watch movies, to listen to audio or music, And this is going to be exactly as if they were sitting in their living room.
At the moment, the Serenade team is still in the prototyping phase, building large-scale in-lab demonstrations. By 2020, the technology will be tested over a real satellite in collaboration with the European Space Agency. Together with partners from the industry, they want to bring their technology to the market as soon as possible.
Everybody is really motivated, thinking that this might end up in the planes that we're using every day, or in the ships, or in some remote area in a developing country where they don't have access to the internet. So this gives motivation to everyone, it gives extra enthusiasm to work hard and try to make it as soon as possible into a real product.